Go ahead, Daniel. Say you're good.
Okay,
Everyone can hear.
So this guy asks his girlfriend to prom. They're seniors. It's their last year of high school. They want to make it a nice night.
Mm-hmm.
And so he puts a lot of thought and effort into his preparations. First, he decides to order some flowers and have them be delivered on the night of prom, like a nice bouquet of roses. It's a bit cliche, but it's romantic. And so he goes to the flower shop, and outside, obviously, it's the week before prom, so everybody's getting their preparations done. He has to wait like an hour to get
his flowers.
To order his flowers.
Yep.
And he orders his flowers, and the line's pretty miserable, but it's all worth it. And then he goes to get fitted for a tux because he hasn't ever gotten fitted for a tux before. And so he goes to the tailor, and again, it's prom week, so the line's out the door. He has to wait a super long time until he's able to get his tux fitted, and then finally, he wants to impress not only his girlfriend but everybody else at prom. So he decides to go to this limo service and show up to prom in a limo. And so for the third time, he's getting pretty frustrated at this point because there's another line out the door. He has to wait like 2 hours to arrange for the limo service. But then it's all done. Preparations are set. Come along prom night. Him and his girlfriend are having the most wonderful time of their life. It's awesome.
Oh my gosh, this is lovely.
And then towards the end of the dance, his girlfriend goes, "I'm really thirsty. We've been dancing for a couple hours. Could you give me a glass of punch, please?" And so he goes over to the punch bowl, and there's no punch line. Oh, I hate you.
Lovely. Brilliant.
Oh, Daniel.
You know what was more painful than waiting in the limo line? Waiting for your joke.
Hi, guys!
I wish you could see the facial expressions of your comrades in arms here. They were so... Thomas looked like he was mildly pained.
It's just because I was thinking about English class.
What?
So bad.
Who did? He did?
Yeah.
All right, tell the English class joke. Go ahead.
All right, we're basically going to say goodbye to half this class if I tell the joke.
Yeah.
Is it that bad?
Let's do it.
It's really long and really bad.
I'm sure we'll survive. I can tell her.
We'll do it.
Go ahead, Daniel.
So, I bet you, they're not even going to hear my voice. They're going to hear me, some mumbling in the background, and then Miss Yam sounding really disappointed. So these three buddies, are walking through the woods. And one of them trips on something and falls. And when he stands up and goes to see what he tripped on, he finds a lamp buried in the ground. And
A leg?
A lamp.
A lamp.
And so he takes this lamp and he rubs on it, and a genie pops out. And the genie goes, "You have released me from my eternal slumber. As a reward, I shall grant all of you 3 wishes each." And so the first guy, right off the top of his head goes, "I want $25 billion. And sort of game show style, this massive check for $25 billion appears in his arms. The second guy looks at the first guy's massive check, and he takes a moment to think. He says, "I want to be the richest man in the world by 100-fold. And then he gets his buzz on his phone. His phone vibrates. It's a notification. And the notification is from his bank saying that his net worth is now $1 trillion. And the third guy goes, "I want my arm to rotate counterclockwise nonstop, my left arm." And so his left arm starts rotating counterclockwise. Now, it's time for the second wish. And the first guy goes, "I want to be married to the most beautiful woman on earth, someone who would outshine any other model there is."
Stupid.
And the genie snaps his fingers, and this gorgeous lady just appears standing next to him and wraps herself around him. Now, second guy goes...
Like a burrito.
Like a burrito? Like a towel? I don't understand.
Just wraps her arms around him.
Oh, okay. All
So
right.
the second guy goes, "I want to be the most charismatic person on the world. I want to be able to get anybody I want." And Genie snaps his fingers, and immediately the first guy's lady starts flirting. Now, the third guy goes, "I want my right arm to start rotating clockwise nonstop." And so the genie snaps his fingers, and his right arm starts rotating. At this point, he's just standing in the forest, and his arms are rotating in different directions. And he can't stop. And so now for the third wish, the first guy says, "I want to effectively be immortal. I do not want to be able to die of old age." And And the genie says, it is done. And the second guy goes, I want to be permanently 29. And the genie says, it is done. And you can sort of see him start to de-ageify a bit. You know, his hair seems to grow a bit more, get a bit more liveliness into it. Some of the wrinkles fade away. And the third guy goes, I want my head to nod back and forth nonstop and my mouth to open and close nonstop. And so his head starts nodding and his mouth continues to open and close. And so about 25 years later, they decide to meet up, you know, check up on each other, because they used to be good friends, but then they moved on, and you know, it's like a reunion of sorts. And so they're all meeting up at a coffee shop, and so far the third guy's late. It's just the first and the second guys sitting at a table and talking about the first guy goes, oh my goodness, my life has been amazing. I've traveled the world off of my money. I've started a successful business, and I have this amazing family. I'm really enjoying this so far. It's been fantastic. And the second guy goes, with my enormous amount of wealth, I've started charities and other organizations across the world and put tons of money into solving a bunch of the world's problems. I've become world-renowned for my efforts, and I still have a ton of money. And then at this point, they turn their heads because they hear this loud noise, and it's the third guy trying to enter the coffee shop. And he's struggling a bit because he can't. It's hard to open and get through the door while your arms are flailing around back and forth. But he manages to get in, and he's trying to order a coffee. And so he orders his coffee. It's the largest size he can get. He looks like he really needs it. And as he tries to go pick up his coffee, he grabs it. But since his arm's rotating, the coffee immediately goes flying out of his hands. And it's a big mess. He gets coffee on his shirt, coffee on his hair. The poor barista got spilled with some hot coffee as well, and he just looks miserable. And so with his empty coffee cup, he comes over to the table, and he sort of dejectedly sits down, and he says, guys, I think I messed up.
That's the joke. That's the joke.
And we will never
It took forever to get through that.
Yeah,
and that's the joke.
Those 10 minutes of our life we will never get back again. Ever. This is 7 minutes of our lives that we will never get back again. Okay.
Make him skip.
Oh my gosh. Okay. All right. I think I'm going to have to.
I said it was bad.
We gotta have a way to make the videos incapable of being skipped.
Okay. Let's begin. Let's do some math. I have to say, I'm a little distraught. Oh, Daniel, you are one of a kind. You broke the mold. When you were born, the mold was broken. That is the truth. That is the truth. You are one in a million.
Except for everybody that was made before the mold.
But you know what? The fact that I think there's something to be said for it. Like, I have this quality too. Like, even if no one else thinks it's funny, as long as you yourself think it's hilarious,
It's funny how bad the joke.
you don't need anything else, right? Like, you don't need your peers.
I like to pride myself on the delivery.
Yes, I would agree, and you should. All right, ready? Let's begin. Let's do this. I have to segue us, okay? So right now, while Daniel was going on his novel, epic, long joke, I kind of set the stage for us. We know how to deal with those limiting forms, those indeterminate limiting forms, okay? We have a class of 3. The good news is the way you deal with these 3 indeterminate forms is the same. And I think, as you're going to see, these are the kind of lessons that I find to be the most boring, because it is literally me just telling you how to deal with these indeterminate forms, okay? First of all, if you are ever at a party and someone says, what is 1 to the infinity? The answer is 1. That's not indeterminate. What makes 1 to the infinity is if it's something approaching 1 raised to something approaching infinity. That's what's indeterminate, okay? So it's really important that when we talk about indeterminate forms, they are indeterminate because of limiting or approaching behavior, okay? So here's the first example. Here's our first limit. The first thing we always do, like we always do, is we just plug in the value of x, right? Okay? So as x approaches positive infinity, what does this base approach? 1 plus 1 over x squared. This approaches what? Oh. It approaches, what did you say? It approaches 1, okay? And what does 2x approach? Positive infinity. Okay. No, it does not, Thomas, this is indeterminate. No, it does not. No, you cannot, you can't even like go, it's
I
1.
like that.
I know you don't. But it's, you know what, it's sometimes, it's like broccoli, you have to just embrace it, right?
Wrong.
It's
You
fine.
have to
Okay.
look yourself around.
If this were, Thomas, if this were the limit as x approaches positive infinity of 1 to the 2x, yes, this equals 1, because this base is 1. It's not approaching 1, it is 1, okay? So when you have 1 to the infinity as an indeterminate limiting form, here is what you do. And I'm literally showing you the steps of how to deal with this, all right? Here's what we do. You ready to do it? Here's what you do with an indeterminate form of this type. And the way you deal with 1 to the infinity is the same way you deal with the indeterminate form 0 to the 0 or infinity to the 0. All right? All right, here's what you do. You call, step 1, you call the argument of the limit y. Okay? So what we're going to say is, okay, let's just let y equal that which I am taking the limit of. Okay? And by the way, right, like the original question was find the limit of y, because after all, we're calling this y, right? So the original limit is on y. Step 2, okay, take the natural log of the thing that you just called y, which is this. Take the natural log of that. Should I pause? Am I going too fast? I can pause.
Just a small one.
Yeah, I'll just pause.
So,
Okay. Yes.
We know that, so 1 raised to the infinity is 1 outside of the context of a limit.
Correct.
But all
Correct.
these other forms, when we take them outside of the context of a limit, are they
Yeah.
still indeterminate?
They're indeterminate or they wouldn't exist. Like, I mean, 0 to the 0. So that's 1 to the infinity is the only one that we can really take out of context. I mean, infinity to the 0, one could argue either way, this equals 1 or it equals infinity, because someone could say, yeah, but you never can get to infinity, so that's one where you could argue it either way.
Okay.
0 to the 0 is a little bit more. You can go either way. You can call it 0 or you can call it 1, right? It's more of just a weird idea. In the context of limits, though, if you have a base racing to 0, if the base wins, the whole thing equals 0. But if this 0 wins, the whole thing equals 1. That's why it's indeterminate. As far as what you'd answer if someone at a party said, what's 0 to the 0? I'm not really sure I have a clear answer on that one. Because one could argue it both ways.
Okay.
Okay? All right. Take the natural log of that, and here's what you get. You get the natural log of y equals the natural log of 1 plus 1 over x squared, all to the 2x. Okay? No, not differentiation. We're taking a limit, Thomas. But you're thinking well. You're thinking well.
I mean, like,
Okay?
if we ended up having to use L'Hopital,
Okay, it's be very helpful. Let's see. Ready? Now, you've done that. Right-hand side, use properties of logs. In other words, this becomes 2x times the natural log of 1 plus 1 over x squared. Okay? This all equals ln y. Alex, you're not taking notes down or anything? No? Jonathan, how about you? You taking notes down? You okay. Okay. All right. So, step 1, call the argument y. Right? Call the argument of the limit y, take the natural log of y, and then here is kind of step 3. We're going to take the limit. We know the original limit was the limit of y. I'm going to take the limit of ln y. Okay? You're probably wondering why, and then hopefully when we get through the whole thing, you'll see why. Yes.
when underneath 2, where you wrote LNY,
Yep.
natural log of,
Yep.
the argument.
Yep.
So I just want to clarify that 2x is part of the argument.
Correct. This is a property of logs, in case you forgot.
But yeah, so we would if we put brackets in, brackets would surround the 2x, correct? Yeah.
Yes.
Okay.
Yes, correct. Okay, just remember that property of logs right there. Okay? Take the limit of ln y. In other words, I'm going to now take, you ready, the limit as x approaches positive infinity of ln(y), which is right here. I'm going to drop that right into the argument. 2x times the natural log of 1 plus 1 over x squared. Hopefully you're wondering, like, why the heck would I ever do this? That question will be answered soon, I promise you. And to answer Daniel's question, if I wanted to bracket the entire argument, I could do this as well. Now we're back to square one. We have a new limit problem. You tell me when I plug in infinity, what do I get? Okay, hold on. That's positive infinity times, oh my, we know how to deal with limits of that indeterminate form. Okay, we can't use L'Hopital's on this, but I can now try and rewrite my argument as a quotient that would then allow me to use L'Hopital's. So if I were to put an emoji right here, I thought, if I were to say like, okay, aha, like I know how to deal with that indeterminate form. It's not L'Hopitalable, but I know that there's got to be some way that I can rewrite this limit as a quotient. What do you recommend? Okay, yes, let's see if we can fix Maya's not even algebra mistake, because it's very common when we get to this level, right? She said this is the same thing as 2 times x to the negative first. Is that what you said, Maya? That's not even what should come down. What cannot come down here? The x to the negative first, that comes, but where should the 2? 2 stays where? Up top, right? Those little kinks in our math, this is when we start ironing out. This is when they kind of surface, because we have our head and our brains on the big picture, okay? Yes, Daniel.
So, when we take the limit of our new argument, aren't we like I'm trying to see the connection between this argument and our original argument. I feel like we're just taking the limit of something different.
Yep.
I'm not sure how it exactly relates.
Hopefully I will have your question answered in about 30 seconds. Okay? All right, let's see. We have a new limit. Ready? As x approaches infinity, what does the numerator approach? 0. What does the denominator approach? This is just 1 over x down here. X and negative. Thomas, this down here is the same thing as just 1 over x down low. 0 in the denominator. Aha! Now why are we very happy? I can now use, Alex, I can use L'Hopital's. L'Hopital's, the hardest thing with doing L'Hopital's is the algebra. Okay, let's use L'Hopital's very carefully. Now, you're going to meet me. I'm going to have you take the derivative of this numerator. Let's see if we can take the derivative correctly. So we're going to use L'Hopital's here. Okay, this becomes the limit as x approaches positive infinity. All right, I'll meet you there. I want the derivative of that numerator. Okay. Okay, it's going to be disgusting. It's going to be disgusting, but we're going to clean.
I'm sure we have Lysol.
You're sure you have a what, honey?
Lysol.
Lysol, oh. Daniel, have you picked up one of these pens in the dining hall? They're little corns.
Oh, the corns, I've seen them. I wasn't sure if we were allowed to take them.
They're good for writing down kernels of thoughts.
I like that. I enjoyed that a lot.
If you have an ear for that kind of thing.
Oh, yes.
You definitely looked all of these up.
Maybe
You had to
have
look all of these up.
around
I bet there was a sign that said it.
Unless you think that's too corny.
Oh, Miss Yam.
That was all from Mr. Landreth. All right, I'm ready. Derivative of the numerator. We'll clean it next. Just give me the straight up derivative. Go ahead, I'm ready.
2 over 1 plus 1 over x squared.
Let's stop. Hold on. 2 over the argument of, all right, times.
Negative 2x to the negative 3, or negative 2 over x cubed.
Yes.
Do you agree, everyone? That is the correct derivative of the numerator. Okay, there's times, right? I can even do this to make it clearer. Derivative of the denominator.
I think I agree.
With which one, Thomas? You're the top? Yep. Are you concerned about this part right here? That one? That part? Yep.
I agree.
Yeah, this is just the derivative of the inner, right? What do we do after L'Hopital's? We always clean. I will see how you clean. Let's see if we clean effectively. We don't take the limit yet, we just clean. Let's see if we remember negative exponents.
I mean, we still haven't fully utilized the policy. We haven't gotten
I have
never mind.
Yes, we have done. Look, now I am cleaning. Okay, I'm going to meet you when I clean. This becomes, right? This is where sometimes we lose ourselves in the algebra, right? We forget things like, wait, negative exponents, and oh no, okay? My eye is coming here, actually. I kind of see this situation here. Negative numerator, that's going to be pause. I can kind of drop that, okay? This becomes 2x squared all over, okay? 1 plus 1 over x squared times x to the third, and I bet I lost something, and I did. It should be, yeah, I'm going to fix it and find it right now. Okay, I'm just cleaning in phases to make sure I don't miss anything. X squared over x cubed, all right, I get limit x approaches positive infinity 4 over x times 1 plus 1 over x squared. Everyone okay with that? I'm going to keep cleaning. We keep cleaning. You clean. We don't rush this step because when you compromise this, the algebra, things always go wrong. Always. Thomas, what does this give me when I distribute? I get
X plus 1 over X.
Mm-hmm. Okay. Technically, this isn't really clean. Why is this not clean all the way? I mean, there's.
You can move X up.
Well, yes, I can move X up. I mean, I can't just go and do this like that.
Yeah.
If this was times, I could.
Yeah.
But when you have a fraction within a fraction, there's a mild cleaning I can do here. What can I do?
Make that X squared.
Like, put these two fractions together by getting a common denominator, and then multiply by the
X
reciprocal.
squared over X.
Okay, so I'm going to beat you there. So this is just, look at all this clean. And this is the thing. If I clean well, the payoff is so lovely. 4 over, okay, this becomes x squared plus 1 all over x. Okay, and this becomes, tell me if I lost you on this is common denominator here, downstairs, fractions, limit as x approaches positive infinity of, okay, 4x over x squared plus 1. All right, now I'm good. Please tell me if you lost how I cleaned. Cleaning, again, from here to here, this one step right here was x plus 1 over x. I multiplied this fraction by x over x to get a common denominator. And that gives me x squared plus 1 all over x. I just wrote on one of your quizzes. When you're dividing fractions, that's the same thing as multiplying by the reciprocal, right? But you forget these things. You forget them when you just don't take the time. The payoff is always worth it, right? All right, now I'm ready. As x approaches infinity, what does 4x over x squared plus 1 approach? It is 0. Jonathan, very good. Now, someone could have said, well, it's infinity over infinity. Should I use L'Hopital's rule? Yes, you can. You'll still get to the same result. But Jonathan figured this out using old news. This is limit as x approaches infinity of a rational function. Higher, more powerful dominant term downstairs, a whole thing equals 0. Okay, Daniel, what approaches 0? Was it y or ln y?
We found ln y.
All right. Here's the big moment. But we said ln y approached 0. The original question was for what does y approach?
That mean it approaches 1?
If ln y approaches 0,
Then
tell me what's happening here. Rewrite this statement here exponentially. Log base e of y equals 0.
So y is approaching e to the 0, which is
Yes.
approaching 1.
Y approaches e to the 0, which is 1. So, and with these indeterminate forms, so at the end of the day, we always conclude this way. You have to write the original limit. So, the limit as x approaches positive infinity, you probably have it in front of you. You have to scroll back up. What's the original limit again?
1 plus 1 over x
Thank you. 1 plus 1 over x squared to the, was it 2x, Risha? Equals e to the 0 or 1. Okay? This is the key right here. You know, like when you go down here and you say, when you say, well, wait, I just found the limit, it equals 0. But it was ln y approaching 0. If ln y approaches 0, y approaches e to the 0, or just 1. Everyone okay? All right? Yes, Daniel.
Is there any particular rationale behind often using the natural log whenever we need a placeholder log, other than
right.
Versus like base 10 log?
You can do base 10. You can do
But
base
I
10.
was wondering, in the mathematical world, what is the log? Is it just arbitrary? Does it mean like ln was shorter to right than ln?
Yeah, I think, I'll look.
Oh, no, Thomas. I think Thomas said it's a lot easier to take the derivative of ln.
Oh, that's a good answer. Yeah, because L'Hopital's rule, when you take derivative of ln x, it's just 1 over x. Right? So the answer is you could take log of any base of both sides, but yes, you just kind of manipulate accordingly when you use the derivative. Okay? The bottom line is, what you like about this is, wow, this is one area where there's like no ambiguity. It's just like math as we knew it before calculus. It's just like, I have this, I do step 1, step 2, step 3, step 4. Where do you think there is a potential for minor mess up? All the algebra. Okay, so you take your time and you go through. You want to do it on your own? Yes. Good. All right, let's do it. Ready? Here you go. I'm just going to pull one off your homework, okay? I'll do this one. Okay, here we go. The limit, right? Let's do this one. The limit, ooh. I know you like the bubble pink, Thomas. I know you do. As x approaches 0 from the right of, okay, e to the 2x minus 1 all to the x.
That's an awfully big limit.
Okay, you have to... Oh, Daniel. You're so funny. Did you hear what he said? It's an awfully big limit. That's a really big limit. You have to show indeterminants. Remember, the 3 indeterminate forms are 1 to the infinity, 0 to the 0, infinity to the 0. We can first show indeterminants. It's 0 to the 0. 0 to the 0, infinity to the 0, 1 to the infinity. Those are the 3. Because 0 to the infinity, Arisha, is not a determinant. Do you know why? If you have something racing to 0 and something racing to infinity, infinity could win, and it's still heading towards 0. Once it hits 0, 0. Right? So that's not the battle analogy. Like, if 0, because if something is racing to 0, it's going to be like at 1/8 or 1/7. But 1/7 to the infinity is 0. Right? So if you always think of the battle analogy, right, it's beautiful. You can work together. Look at someone next to you. Just don't get Daniel started on another joke.
Well, you know I would.
I know, we know. But although I'll say this, you know what, Daniel? Our math class, don't you all agree our math class would not have been the same without Daniel?
Yes, because then you would not be.
Honest, the truth.
That's a good joke. It would have been warmer. It would have been warmer.
That's true.
It's not my fault. More easily.
The first step, I hope you're all doing this. The first step is you have to show this is approaching 0 to the 0. You have to show indeterminants. You have to show that step. Okay? Then you can just go down here. You can just write this. You can just say this is all the work you have to show, let y equals e to the 2x minus 1 all to the x. You can just do that. And then show that you're taking the natural log of y equals the natural log of. Okay, then use the property of logs to swing the power up front. Okay, and this is ln y. And now you're taking okay, that's where you should be. So I kind of modified our lesson today to be a very dry, just step by step. There's very few of these left. More time, Thomas?
Sam, did you ever try the chicken vegetable soup today? I was hoping to be able to catch you before lunch, but I wasn't able to find you. Well, I wasn't able to find time to find you.
I didn't try. Was it good?
The chicken vegetable soup was good, but I felt like the hotter it was a bit better. Like, once it started getting warm, but not lukewarm, the quality went down a bit. Also, I feel like the first bowl was a lot better than the second.
Yeah, I didn't have room for soup today. I just got the fish.
No. Alright.
What did you have for lunch? Didn't cut soup. Just
I had the soup. I also got some of the chicken. They're really good at making sauces, but they always use chicken breast, and it always gets so dry. Hey guys, bit of advice. Whenever you see the rosemary chicken, always go for it because they use dark meat for that chicken, and it's so juicily delicious.
Right. And why is dark meat more tender than
Oh, I know that answer as well. Because the dark meat is located it's like chicken thighs. That's often considered dark meat, and that's because the muscles in that region are used a lot more by the chicken. The muscles in the breast region correspond to the chicken using its wings, but chickens don't fly very often, but they walk a lot, and so the muscles are far more used where the dark meat's located, and that's actually part of why the meat is darker and why it's more tender.
Right.
He's very passionate
But
about
does dark
dark
meat
meat.
actually help you? Or dark meat has a higher fat content, and like what I don't want to get started on my low carb rants, but consuming like the fat in dark meat is not unhealthy at all. Obviously, everything in moderation, but even still, it's like the American food industry completely vilifies fat as a universal bad food, a bad nutrient, and that's nowhere near the truth. So, I mean, like, you're gonna be fine eating dark meat. The things you probably want to avoid overall are like the oils and fats and fried foods.
Yep.
What is the natural log of e to the 2x minus 1 approach? Well, I agree, Thomas, the argument approach is 0. But what does ln of 0 approach?
Negative infinity.
Negative infinity. Let me give you a quick refresher. The graph of ln x looks like this. You don't like it? This is the graph of y equals ln x, asymptote at x equals 0. Okay? So as you approach 0, do you see how, right? As you approach 0, ln x approaches negative infinity. Okay? So we've established this indeterminate. 0 times negative infinity. We're heading in the right way. Okay? Rewrite the limit. Limit x approaches 0 from the right of... How did you write this, Cameron? Did you write this a certain way? How did you rewrite this? Yeah, well, first I was just asking you how you rewrote it, but did you write you wrote it? Okay. This then equals all right. We are at a place where we can use our good friend L'Hopital. Okay? Limit as x approaches 0 from the right. All right, watch yourself with these derivatives. All right, Cameron, ready. What's the derivative of the numerator? Yep, derivative of that is? Derivative of that.
Yeah, I just thought that was adding something. Plus. I was listening to the
No, you're thinking of the derivative of e to the 2x is e to the 2x times 2. The derivative of natural log of blah is 1 over the argument.
Yeah, but I thought it was multiplying. Oh, wait, there's no x there. Oh,
It's
is that
1
guy
over e to
like
the
that?
2x minus 1 times 2 that's 2x.
That's the derivative of the numerator. All over.
Negative x.
Okay. I'll meet you after you clean. Let's see how you do when you clean it. Mm-hmm. I see a way to clean this, though. I don't know if you guys do. Yes, Cameron?
How come there, you know how it's originally e to the 2x minus 1 in that quantity raised to 5x? We lose the x somewhere.
We multiplied x up to the front, and then we brought x to the bottom.
Oh my gosh, I forgot to bring it. When I brought it to the bottom, I forgot to take it away from the top.
Oh,
If Cam, you got it.
that would do it. Okay, how are we doing here?
That's as far as I got.
That's great.
Now you're stuck. Okay, so now I'm looking at this. Actually, I was saying something else. You know what? I don't see a way to clean this anymore.
How did you get it?
Let me do one. No. Hold on. Everyone, this is a great question. Hang on a second. I'm going to write it this way. This looks a little bit nicer. All right. This is a great example. I just plucked. Excellent. Nothing else I can clean, right? What do we do now? Limit. Plug it in. When you plug it in, limit as x approaches 0. What's the numerator approaching? 0.
Correct.
Guys, come on.
0 to 0.
0 to 0.
Oh, wait.
Over.
0 squared.
All over.
0.
And what do we do? L'Hopital's again. Now, and here's the thing. You know how we know we're in the right direction? Because we tried everything. Like we know we are doing nothing wrong. Now, look at that numerator. L'Hopital's again. That derivative of the numerator has to involve what?
Product rule.
Yes, indeed. I'll meet you there. Okay. Woo! Am I happy now?
Oh, factoring.
I am going to clean. And if you clean well, in the numerator, I'm factoring an e to the 2x out. This is the thing that just makes me so happy. If I factor e to the 2x out of the numerator, I get limit x approaches 0 from the right of negative 4x minus 4x squared all over 2. Oh, I'm still cleaning. Stop it. Don't even insult me with that. I'm going to keep cleaning. Negative 2x minus 2x squared. Are you kidding me? At the end of the day, this whole thing, the limit just equals what? I'm just going to double check that. Hang on, I'm just double checking all this.
I don't like it.
Oh, Thomas, hush, hush now. Wow. Limit, do you agree? Equals 0. And I'm done, right?
No.
No, you are not, Maya. Why?
Because you took the natural log
Yes.
of y.
The natural log approaches 0. That means y approaches e to the 0. Okay, that's a coincidence that we have the same answer.
Yeah.
Had this been, just so I'm clear, had this been ln y approaches 2, that means y would approach what? E to the 2, or e squared. Okay? If ln y approaches negative 6, y would approach e to the negative 6. Okay, well, hold on, wait, don't, you're still packing up. 1 second. So you have to write, therefore, the limit as x approaches 0 from the right of, I have to go all the way back up. See, I know you're all being very, very, like you're neglecting your work here. E to the 2x minus 1, of e to the 2x minus 1 all to the x equals e to the 0. Dun, dun, dun. Okay? It is over. That is your, again, that's our next set of 3 indeterminate forms. Okay? You don't like it? I love it. I love it. Oh, I'm going to start,
I'll go on.